Hello class. As promised in the earlier videos, I will be discussing about the law of conservation of mechanical energy in this lecture video. Okay. I've chosen to directly discuss this because, wait, where is that? Yan. Oh, ay, there. Ayan. So, by directly discussing about this fundamental law, the law of conservation of mechanical energy, we'll be able to uh, connect all the kinds of work done by the different forces that we have mentioned in the earlier videos. Okay? In the reference by Young and Friedman, we actually have two chapters no, discussing work and energy, but we just did it in 4 to 5 videos because I just highlighted the most important ones. But it doesn't mean that you will not read the entire chapter, of course. So let's start. The law of conservation of mechanical energy. I hope that at this point in time, uh, you already know what mechanical energy is. So mechanical energy, this is actually the summation or the total of the kinetic energy and the potential energy. In the previous videos, we've already talked about two kinds of potential energy. We already encountered, ayan, my dog is barking. Okay, let me pause this for a while. Okay, where was I? It's quiet for a while. And I don't know when the piece will end. Ayan na naman siya. Okay, sige. So, I think I stopped somewhere in the kinds of potential energy that we already discussed in the earlier videos. We have the elastic potential energy, and we also have gravitational potential energy, the U gravitational. If we are able to reach until electricity, then we would be encountering another kind of potential energy, and that is electric. No, pag electric charges na U elect. So we just focus on elastic potential energy and UG. Okay, so the law of conservation of mechanical energy is, I've been repeating this as it's one of the most fundamental because up until now, there has been no violation no, or any discovery that tells the otherwise. So if we put it beautifully in a single and complete equation, it's just saying that uh, the famous line that energy cannot be created nor destroyed, but it only transforms from one form to the other. So what we're saying is, since the beginning of the universe, all of the energy that it has before the cosmic egg uh, had its big bang, no? Yan. Uh, Data is telling us that the energy of the universe initially during its birth is just the same as of the energy that we have up until now, and then it continues to transform from one kind to the other. So if the energy it's not created, it's not destroyed, it has been there, science cannot explain kung saan siya galing, no? So we just say therefore that whatever changes in the forms of energy that we have, then the total of all these changes would be zero. So that whatever energy that the universe has in the beginning, ganun pa rin siya until now. It just changes nga from one form to the other. So we say therefore that the change in the kinetic energy of a system, let's go to a small system muna. although it's applicable to the entire universe. The change in the kinetic energy plus the change in the potential energy. So in this case, I will be putting these two kinds of energies, no? Hindi ko na muna ito isasali, but alam natin na merong ganyan na form. So the change in the gravitational potential energy plus the change in the elastic potential energy. Okay? So if you have here kinetic plus potential, this is total, the change in the total mechanical energy. Plus, we also say that uh, the change in the internal energy of a system, isa-isahin natin yan mamaya, the total of all of this is zero. This is the fundamental and almost, bakit triangle ang pinili niya? Fundamental and the almost complete na, no? Kasi nga hindi natin sinali si U-elect dito, U-electric. So what does this tell us? The change in the kinetic energy, okay, we learned earlier that this is equivalent to the total work on the system. Tama ba? And then, these three kinds of changes refer to the change in the mechanical energy. So total mechanical energy, or symbol is capital E. K plus U equals E. And then, itong si delta UG and delta U elastic, this is equivalent to the work done by conservative forces, di ba? Work done by F conservative, such as gravitational force and spring force. And then the internal energy actually is equivalent to the work done by other forces. When I say other forces, this would be the non-conservative forces. So non-conservative. Very concrete example of the difference of the two is this. The work done by conservative forces does not depend on the actual path taken, whereas the work done by non-conservative forces is really affected by the actual path taken by the particle. So these non-conservative forces, we will call this, so this is also known as, pwede natin siyang bigyan ng generic na term as other forces. So F, other na siya. Pag sinabing other forces, ito na yung any force that is not conservative. No? Kasi nga conservative force na isinali natin dito, gravity at saka spring force. So when analyzing a system, other forces, this would be non-conservative forces, specifically and usually, this would be friction. Kasi si friction, this is non-conservative because the actual path taken by the system uh, greatly affects the work done by friction. Okay? Another can be pwedeng tension, no? So kung meron kang sinali dyan na tali tapos sinila, then that tension there does a work, and the work there can be considered as the work done by other force. And then what are other things? Pwedeng normal force, etc. As long as these do not include gravity and spring force. Kasi yun nga yung conservative forces natin. So, since we call this as other forces, so the work done by other force, pwede na lang din nating tawagin as work other. The work done by other force will always be happening in the initial state of the system. So what do I mean by that? So further simplifying this in a system, si delta K, di ba, this is, when we have delta, that's final quantity minus initial quantity. So the delta K here becomes final kinetic energy minus initial kinetic energy plus, you have UG here, there's no negative, so this is UG2 minus UG1. So we have UG final minus UG initial. And then, the elastic naman dito, walang negative, so it's another plus U elastic final minus U elastic initial. Okay? And then, the change in the internal energy, this is contributed by the work done by other forces. So for example, yung work na ginagawa ng friction, it's always negative because the friction will always oppose the direction of motion. So it somehow gets energy from the system, no? Kaya negative ang work ng friction. But dito, in generic, ipa-plus na lang muna natin. So we have work by other forces. So actually, itong sign plus natin dito sa work other, this can be positive, this can be negative. No? A negative example is the work done by friction. And then we have zero here. And then we further simplify this into something that is more common to us. So all of the energies that are involved in the initial state of the system, meaning yung mga energy dito na may subscript 1, they should be in one side of the equation together with the work done by the other forces. And then, so we have, and then all of the kinetic energy final will also be in the other side of the equation. Okay? Ayan. Oops, I think I am missing something here. I'm missing something, sorry. The change, ayan na naman sila, tumatahol na naman. The change in the internal energy of a system is equal to the work done. Okay. Wait lang guys. Masyadong maingay. Okay, let's continue. Hay nako, walang noise cancelling itong Zoom ko. Okay, sana tayo. Let's go back to the important thing that I overlooked. So the change in the internal energy of the system is equivalent to the absolute value of the work done by the other force. But specifically, we say that delta U internal is equivalent to negative work other. So for example, since the work done by friction is negative, so if we have negative minus negative, this becomes, sabi ko? The work done by friction is negative, it will increase the internal energy of the system because it will cause the two surfaces in contact to heat up. So the work done by friction, I think I've mentioned this in earlier videos, it's equivalent to thermal energy. It will make the system warmer. No? So it's a negative work done by friction, but it's an increase in the internal energy of the system. That's why you have the negative sign here. So lagay natin dito negative. Excuse me. Ayan. And then, we now put in one, let's group together all the energies involved in the initial state and in one side, like mentioned earlier. Tapos lahat ng mga may subscript 2 sa kabila. So since lahat ng may subscript 1 dito negative, pati ang work other, itong si work, ang ginagawa na work ng other force, nangyayari diyan in the initial state. Kaya kasama siya ng mga may subscript na 1. So we can put all of these negative energies, put the negative energies, ito at saka ito on the other side, but we will flip it again such that dito na rin sa left si K1. So mathematically lang, such that this actually becomes kinetic energy initial state plus UG initial plus U elastic initial plus the work by other force. Okay? Actually nga, this is plus or minus, depende sa ano. Pero pag obvious ng other force is friction, automatically sa equation nyo, ima-minus nyo yan. And then equals, you have your kinetic energy final plus UG2 plus U elastic 2. So this is now our complete conservation of mechanical energy equation that we will be using in any system. So pag klaro sa problem, for example, na walang spring, walang friction, it's just a change in height. Therefore, itong equation natin na every time another dog passes by outside, the other dogs get crazy. So that's what's happening while I'm recording this video. Hindi na ako mag-pause. Bahala na yan dyan. Isipin nyo na lang na ano siya, background music. So, let's talk about common cases that you'll encounter in problem solving, no? As we apply this conservation of energy. Our first case, simplest case would be, what if the only work that does, the only work that does force, the only force that does work is gravity. So if we say, in other words, if only gravity does work. Okay. Meaning to say, walang other forces. Walang other force, it's zero. At saka walang spring force din. Ayan. So what's involved now would just be kinetic energy and UG. So our equation here, this one, hindi mo na ilalagay ngayon CU elastic at saka CU other. So immediately, you just place there K1 plus UG1 is equivalent to K2 plus UG2. Bakit? Because in the original form of the conservation of energy equation, there's no elastic potential energy initial, there are no work done by other forces, and there is, of course, no elastic force in the final. So you only have mechanical energy 1 equals mechanical energy 2. So it's very obvious here that the total energy is conserved because ganun pa rin si E2. Tama ba? How does this happen? So sabi natin earlier, in earlier videos, uh, the work done by gravity is only affected by the initial and the final points. So, pwedeng ang system natin, pwedeng either vertically, andito siya at a certain point, point 1, and then later, andito na siya, point 2. So, ayan, tapos no air resistance. May other force ito kasi akyat man siya. Baliktarin natin, from 2 to 1. So, it's just falling. No? Natural, from high potential to low potential. So, binaliktad natin ha. Ayan. Kasi pag paangat siya, while doing it up, merong normal force no, sa kamay ng kung sino man. Or pwede rin namang ang system mo is nasa ramp. So, sasabihin na walang friction, kinetic coefficient of kinetic friction is 0, and then the point 1 is there. So, since very slide ito, kasi nga 0 siya, if you release this, so initially hindi siya gumagalaw, somebody must be holding it. After releasing it, it will accelerate kasi it's from high to low potential. So in that case, since merong change in height, then merong change in gravity. Walang other force kasi walang friction, tapos walang spring force kasi walang spring. So pwedeng ganyan. Yan. So in that case, ito, simplify mo na lang siya. So you have 1 half m v1 squared plus mgy1 equals 1 half m speed 2 squared plus mgy2. And then it depends na now on the problem, whatever quantity is being asked. No? In this case, you don't need the mass, magka-cancel siya in this particular case. So, ganyan. If initially it's not moving, so lalagay mo kaagad sa figure mo na walang initial speed, so yung K1 mo ngayon magsi-0. Hindi mo na ito isusulat, diba? So in that particular case, and then let's say bumagsak siya dito sa ground such that Y2 is 0, edi wala na itong UG2. So basically, ang nangyari ngayon sa equation mo is very clear that whatever potential energy that the system has in the beginning, that has been converted to motion kasi naging K2 yan before siyang mag-stop pag nakalapag na siya sa land. So, yun yung physical meaning ng equation mo dito. UG1 gets converted to K2. Okay, let's continue. What if this time, the only work, so if, okay, lagyan natin ng, let's say, ang case 2, gravity and friction. So, if F, G, and friction, kinetic, do work. So, pag ganyan, our equation would be, yan. So, we'd say that, pwede ka actually magsulat ulit sa complete form para lang yung thought tawag yan, yung train of thoughts mo, ano siya, parang may sequence. So, UL1, tapos meron ka na ngayong work other, kasi may other force na, may friction ka na, equals K2, UG2 plus UL2. So there's friction, there's gravity doing work. A very good example is the figure that I shown here. So ito. Pero, hindi ko siya gagawing zero. Meron siyang value na mu k. So pag ganyan, the change in the position is downward, but you have gravity somewhere here. Gravity is still vertical. So if we, I'm sorry, gravity is still vertical. Yan. Vertically down. So kung gagawa tayo ng free body diagram ngayon ng system natin, meron kang mg, ito. If this is theta, alam natin that this is also theta. So pakita mo na kaagad, ito yung mgx, papuntang negative, kung magne-negative tayo pababa. And then, meron ka ring negative mgy. And then, you have the normal force here. And then, you have friction na opposite direction. So, si N is 90 degrees with the S. Kaya, the work done by normal force, even if normal force is another force, wala pa rin siyang work. Kasi, ano man siya, dito siya, ganyan, pero si displacement is 90 degrees, so walang work siya. Si MGY, wala ding work kasi 90 degrees din siya with S. So, merong ginawang work dito, si friction at saka si MGX. Kuha ba? Ayan. So, that would be the case. So, in our equation here, since alam mo na walang spring, edi tanggalin mo na, walang spring sa initial, walang spring sa final. Tapos sinabi initially at rest. So, walang kinetic energy 1. Ano pa? Bumagsak na siya dito sa last, sa final, wala na siyang height. So, ito tatanggalin. So, anong natira sa equation natin? We say that whatever is the initial UG of the system, mababawasan yan ng work done by friction. So, negative work by friction. Ito siya. Si work other magiging minus. Kung ano ang natira dito, yan na ngayon ang magiging energy para makamove siya. So, that's the physical meaning of this equation na nakuha natin from conservation of energy. Diba? Nakuha ninyo sa left side, UG yung total niya, initial, minus yung kukunin na energy ng friction kasi nga mako-convert to heat. So, habang pabagsak siya, although pabilis siya, pero ang speed niya upon reaching the end of the ramp would have been faster kung wala si friction. Okay? It's something like that. And then, so yon, ganyan ang pag-interpret ng equation. Tapos, simplify mo na ulit, this becomes mgy1 for ug1 minus, how do you get the work by friction? So, work by friction is still negative. Ayan, nilagay mo na si negative. Force, the force is friction, kinetic, times the displacement, the S. So, this becomes, tapos, kung alam natin ang value nito in X, pwede na actually equals friction, kinetic times X. So, this becomes kinetic friction times, let's say, x sub 2. Kung equal siya kay x sub 2, o pwedeng s na lang. Basta distance between initial and final yan. And then equals 1/2 mv2 squared. And then do not forget that kinetic friction is, you have mu k times the normal force. So yung na-learn nyo sa Newton's laws, applicable pa rin. In this case, pag pabagsak siya, walang acceleration in the y-axis such that the normal force is just equal to mg cosine theta. So, pag nag-simplify ka, kunyari lang hindi binigay si friction, kunyari ang binigay is mu k, edi kailangan mong i-simplify. Magiging mu k mg cos theta. Tama ba? For this particular example. Tapos, magdepende na yan kung ano yung pinapahanap sa iyo. Sometimes, pwedeng si coefficient of kinetic friction ang pinapasolve. Sometimes, si final speed, sometimes si height, etc. Depende na sa problem. Okay? I hope you are somehow getting the sense of it, no? So, let's go to case number 3. What do you think case number 3 is? What if only F spring does work? F spring does work. So, walang friction. Okay, what do you think? So, from the original equation, we'd say na magiging ano na lang siya, K1 UL1 equals K2 plus UL2. Okay? Pag sinabing initially moving, tapos finally nag-stop, edi, so what do I mean by that? That would mean na, let's say for example, initially, merong spring dito. Yan, natural length siya. So that ang initial stretching or compression is 0. And then let's say meron kang mass dito. Point 1. It's moving at speed 1. Goes there. So that's the initial state. Tapos sinabi no friction. So coefficient of kinetic friction is 0. And then ang second state niya would be, let's say, this compresses that one. So dito siya ngayon, 2. So lahat ng kinetic energy niya naging 0 kasi i-compress niya itong spring ngayon. So meron kang compression ngayon na x2. So kung dito, K initial is the total energy and U elastic 1 is 0. Pagdating naman dito, K final becomes 0 and all of the mechanical energy final is the one that is stored in the spring. Diba? So in that case, ito ang isi-zero mo pag alam mong huminto yung object pagkatapos ng interaction. And then initially, walang compression si spring, so walang UL1. So physically, it's telling us here that whatever is the kinetic energy initial of the box, that will be converted to U elastic final. Yun yung store niya dito. Kung merong friction, so if mu k is not 0, then merong kinetic friction dito na gagawa ng negative work. So yung equation natin, pag meron ng friction, will actually become K1, whatever the kinetic energy here, mababawasan siya ng energy kasi iinit yung floor at saka yung box because of the work done by friction. Whatever is left here, yun na yung magiging ma-store sa spring. So that's the logic of it. Okay? Now, in the problem set, there is a combination. Merong ginagawang work si spring. Tama ba? Let me look at it for a while. Frictionless. Hindi ko pala nilagyan ng tawag nito. Saan naman ko? There. So, what if gravity, spring force, nanatanan, and friction, kinetic, do work on a system? So a very good example would be, say for example, say, yan. So say initially, andito yung box mo. So pwede natin siyang lagyan ng initial kinetic energy or hindi. So let's just say meron siyang initial speed. So meron siyang K1. And then pipili tayo, let's say the horizontal line is our reference for Y is 0. And then lalagyan natin si ramp, no friction. Pero pagdating dito sa horizontal surface, meron ng kinetic friction. And then somewhere here, there is a spring. So, initially, wala siyang kasi babagsak pa siya. So, mangyayari ngayon, let's say if the question is, what is the maximum compression of the spring? maximum compression of the spring. If it started at a certain height from here. Yan. Tapos, hulog siya dyan pagdating dito. Yan. Tapos, so, the box now, after some time, will be compressing tapos dito na siya at a certain point. And then, pwede natin siyang i-divide into events. So, si event 1, pwedeng point 1 to point 2. And then, pagdating niya dito ngayon sa point 2, kasi walang friction dito, whatever is the speed 2 here, yun pa rin ang speed 2 dito sa first part ng horizontal. Yan. And then, punta siya dito ngayon until, let's say, here. This would be event 3. So, merong dalawang events from 1 to 2 and 2 to 3. So, pwedeng ganon. Yan. So, from events 1 to 2, wala pa mang involved na spring. So, pwede mo lang sabihin muna na K1 plus UG1, walang friction, equals K2 plus UG2. Tapos, from this equation, makukuha mo si speed 2. Whatever speed 2 na makukuha natin ngayon, it will become the speed na naman for 2 to 3. So, this would be between 1 and 2. And then, pagdating sa between 2 and 3, between 2 and 3, that would be, meron ng friction, di ba? Ay, sorry. Yan, so meron ng friction. So, ang energy equation natin becomes, the initial here becomes kinetic energy final plus, there's no change in height anymore between 2 and 3. So, we will not write UG2 and UG3. Diretso na tayo sa U elastic. So, U elastic 2 minus the work done by friction equals K3 plus U elastic 3. So in this case, at point 2, there's no compression of the spring yet. So we take this as 0. And then in point 3, the box can no longer move because it has spent all of its kinetic energy, naging potential elastic na. So V3 here is 0, ka-cancel natin to. So that, physically, we are saying here that, dito no, ito pala 0 pala ito. Ayan. So between 1 and 2, you have kinetic energy and UG becomes final kinetic dito sa bottom ng ramp. Pagdating dito, whatever kinetic energy sa bottom ng ramp, mababawasan ng work by friction, and whatever is left there, that will be stored in the spring as U elastic 3. And then you simplify these things, tapos makukuha na natin ang maximum compression. So we can simplify this as 1/2 m speed 2 squared minus friction times the actual path taken. Ito siya, from here to here. This is the actual distance where friction has been working. Equals, work elastic is 1/2. And then you need the spring force constant, di ba? I mean the spring constant or the force constant, the K. And CX3 ngayon, CX3 actually will be the maximum compression. Yeah. So this is an example where the conservative forces and non-conservative forces are doing work. But in the problem set is isahan lang siya. No? Sa problem set natin sa work and energy, I think that's the last problem there. Dito mismo nilagay si spring. Tapos merong box yata dito. Ayan. So in this case, you can just have two points, point 1 to point 2. Ayan. Okay. So do not expect that you understand all of this in a single viewing. No? You need to keep on reading. You need to keep on viewing this until you get it. And a very good way of understanding this better is to choose exercise problems from our textbook. Try it on your own before looking at the answer key. Okay? I think that I would be stopping at this point. Ayan. Okay. Stay well. God bless.